Namaskaram everyone. Welcome back to the 25th episode of our Master Unreal series. And in this episode, we are going to implement turn in place. I'm going to guide you in detail how to implement the turn in place, what are the cases that you have to cover, how to handle the root bone rotation and all. So if you are not following the series, I highly recommend you do that. We recently completed the distance matching in the last two episodes, and this would be the one where we will wrap up the turn in place. So without wasting any time, let's get started. Alright, so we are in our editor now. First, I would like to go through the two changes that we missed in the last episode. So for this, I'll go in the ABP base, and in the select locomotion direction from angle, this should be the angle. So I'll get the angle that is coming in the function input. Alright, and the dead zone, you can make it 10 or 5, whatever you like. I'll keep it 5. And then if I play, I can try in the bottom left and it works fine now. Okay, so let's go to the turn in place real quick. So let's start from the first step. When you rotate your mouse, your character rotates as well. Do you see the feet sliding? Although the foot placement is taking care of the placement of the foot. But the core thing that you need to understand here is that to implement turn in place, you have to control the skeletal mesh. You want it to rotate when the certain threshold is crossed. So if you are rotating your mouse normally, you should be able to look around without rotating the character's mesh. And once you cross a certain threshold by let's say 90 degree or 60 degrees, then we want our character to rotate smoothly with a proper animation that we have for the rotation, that is turn in place. So to control this skeletal, we have to play with its root bone. So if you rotate the root bone, the entire mesh will rotate with it. So that's what we are going to control. So I'll go to my ABP base NM graph. This is what we did so far. I will first break this inertialization node. Actually, it should be placed after everything is ready. All the additives and all that are applied. Then we would like to do this inertialization. And now once this inertialization is done, we would like to control the rotation of the root bone so that when I move my camera around, the character will not rotate until I change the yaw. So let's experiment with the yaw. I have set it to 60 degree at this moment. And now if I see my character, it is placing in this direction. So you see the rotate root bone controls the rotation of the character. If I keep it 120, you will see the character is facing this side. So now you understand how you can control the rotation of the root bone. Now this yaw has to be calculated dynamically. So we will just remove it and we will bind it with our rotation yaw offset. So earlier we did this using this formula. Now we are not going to use this. So from update velocity, just delete it and you can place it directly here. First, we need to know how much you have rotated. So for this, under the update rotation data, and we will create this variable yaw delta since last update. So from the last frame to this frame, how much you have rotated your mouse around the characters. That means along the z axis, we call it yaw. So first we will set it, then we will update the rotation, because at this point this character rotation variable has the rotation from the previous frame. So we will subtract these two and then we will get the change, which is nothing but the delta. So I'll break this rotator because I just care about the z axis, that is yaw, and I'll break this too. And then I will subtract from the current, and after subtracting I'll just plug this here. Okay, so this is the change from last frame to this frame. So we also want to know the speed. So we will say yaw delta speed, and to get the speed we will just divide it by the time. So safe divide in case the delta seconds turn out 0. So this is the time. Now we got the yaw delta speed, and we can set this new rotation of the character in the character rotation, and we would like to set the yaw delta since last update to 0 if this is the first frame update. So we'll use this variable that we created earlier. So if it's a first update, then there is no change. So just compile it. Okay, now we will set up the state machine, and I'll open the locomotion idle layer and I'll change this idle state machine max transition per frame to 1, like we did in the start distance matching episode. And now I'm in the idle situation. So I will transit from idle to turn in place. And once I turn, I want to recover. So I'll say turn in place recovery. And once the recovery is done, we will go back to idle situation. So when will you play the turn in place rotation is when your root yaw offset is at least greater than 15, no matter in what direction. So if you have moved your mouse such that the root yaw offset is greater than 50 degrees, then we will allow the transition. That means the turn in place rotation will play out. Okay. And now let's start from this first. I will bring the sequence evaluator. So first we will make the explicit time dynamic because we want to control it, and let's not expose it. And we want the sequence to be dynamic as well because we can switch between the sequences. We will bind this function and we will name it setup turn in place animation. And we will set the explicit time manually here, and we will get the convert to sequence evaluator. We have set the time, it will start from 0. Now we can hit compile. It's fine. Ignore the warning for now. Then we want to update our animation frames. So I'll bind another function, name it update turn in place anim. In case you switch the animation before the animation ends. So set sequence with inertial blending, pass the context to context, convert to sequence evaluator, and this would go here. Now how do we know which sequence to play? So let's create a function because there is a left and right, and that too in a crutch and stand state. So select turn in place animation, and now we will return the animation. For this we need the animations. I will create them turn in place left, and I'll keep the type anim sequence object reference, then add 3 more, name them turn in place right. So this is for standing. Then we have crutch, turn in place left, then we have crutch, turn in place right. Okay, so first we need to choose in the right, then we will choose from the left. First we need to know the direction, so I'll press select, and I need direction, so I'll ask in the input, give me the direction, and I'll get the direction here. So if the direction is greater than 0, then I'll turn in right, otherwise I'll turn in left. So I'll do select, pass it here. Now whether to choose the crutch or standing, that we can check from the main animation thread. So use the property access. I'll get the crutching. So if crutching is true, then we'll get the crutch, otherwise the standing one. Okay. Then I can duplicate this 2 nodes and I can do the same thing here. Alright, and then I plug this here. Now this will be passed here. And I can make this function pure and thread safe since it is not modifying or changing anything externally. And I can get the sequence here. So select turn in place animation, and the direction is something that we will get from the variables turn in place rotation direction, and this is what I will pass here. And now we will bind another function here, and this will set which direction is that. So I'll set it here. I'll get the root yaw offset. So if the root yaw offset is negative, then we will pass the positive, otherwise we will pass the negative. So why is that? Because so if your camera is like this and if you rotate in the right, then it will give you a negative root yaw offset. If you rotate in the left, then it will give you the positive. So we will just multiply so that we can pick the correct animation using this condition. So whatever comes, I'll use sign. This will give me -1 or +1, and I'll just multiply by -1. So if it is negative, then it will become positive, and if it is positive, then it will become negative. And let's change this to setup turn in place rotation states. Now there might be another question popping up in your mind, that is why we are setting this on become relevant here and not here. I mean, we have used this on become relevant of evaluator most of the time, then why we are setting this in the output animation pose? The reason is when this state will become active, both the on become relevant will be called. So the reason is when the blending is happening between different animations, on become relevant is called multiple times. So in the single frame, this will be called multiple times, but the on become relevant of the output animation pose doesn't care about what is happening here. So this will be called only once. So that is the only reason we are putting it here and not here. We just want to update the direction once because we have nothing to do with the animation sequence or frame. That is the sequence evaluator's job. We only care about the direction, and that's why we have isolated that logic here, just to avoid doing the same thing multiple times in a single frame during the blending. Okay. Now we can go to turn in place rotation to recovery. So when do we want to transit to recovery is when the turn is successful, and then this is the recovery. Okay. So as soon as the weight reaches to 0, then we will play this animation. So you see this giant spike. So we do not want to handle this spike in the same state. That's why we have separated the same animation in two different states. This is the rotation and this is the recovery. So in that case, we would like to know when the turn in place is over, and to check that we will access this curve value. So to access this value, I'll use get curve value, and the curve name is the turn your weight. So I can just copy it from here and I can paste it here. Now if it is almost equal to 0, then in that case you can play the recovery animation. The reason is, let's say even if you are rotating in middle of that, you again rotate it, you will still stay in the turn in place, and in the on update the animation will be switched. So you will never get into recovery until the character turns completely, because there is a possibility in middle of turning you just shift your mouse again in the 90 degrees. So in that case we just want to switch the animation and we would like to turn in that area. So we do not want to do the recovery at that point. So that is the reason we are doing this in a separate state, and then we will automatically transit to idle if the recovery is completed. So now we know the value, but we need to know the time. When do we start? So we need to tell the time. So I'll create a sequence player. Since we have nothing to do with the curve value or speed or anything, we can use the sequence player, and the sequence would be dynamic, and we will use the on update turn in place recovery anim. We will get this convert to sequence player, set the sequence with inertial blending as usual, and we need to select the sequence. So use the select turn in place animation and use the rotation direction. Okay, pass the context. But this animation we have to pick the correct timing. So to get this timing, we have to create another variable. So let me close everything, and this should not loop. I'll create turn in place animation time. So this is the time from where we have to start playing this sequence. Okay, so I'll change this start position to turn in place animation time, and we can hit compile. Go back in the turn in place rotation. We also have to disable the loop because there is no looping. And now we need to update that turn in place time as the time passes by. So first, when the on become relevant is fired, that means we will set it to 0. And then as the frames are played, and here we will use set explicit time. Why we did this is because in the start and stop distance matching, we were calculating the distance and we were using the curves to pick the value. But here we need to tell the time because there is no distance matching. So that's the reason we created this variable. This will keep accumulating the time and we will pick the frame accordingly. So first we will update the time as the on update runs every frame, and that would be get the context. This will give you the delta time, so the time between the last frame and this frame, and so far how much is played, and we will add them and we will plug it here. And then we can get the node again and convert to sequence evaluator pure function, the green one, and we can pass this here, and the time would be this. So now this evaluator will pick the frames based on this time, and as soon as the turn in place is over and the distance is almost 0, we will transition to recovery, and the remaining animation will be played in this state, and we will transit to idle. Correct the spelling here. Okay, now we need to calculate the root yaw offset. So let's go to ABP base, and we will create a function to update the root yaw offset. And this root yaw offset will be updated after the character state is updated. So I'll call this here, connect this, and this will require the delta time. So input delta time, and we'll change it to float. Get the delta time variable that is from the blueprint thread safe update animation node, and make this function thread safe. Hit compile. And now we will calculate this. Okay, so this is another project where I have implemented turn in place. I want to demonstrate the use cases or situations where we have to adjust the rotation. One is that if you cross a certain threshold, then our character should rotate itself like this. Another situation is if I do not cross that threshold, then I have to adjust the root bone manually. Now the question arises, when do we have to adjust and when not to adjust? So there are two situations. Either you are in an idle situation or you are in the movement situation. These are the only two possible cases. So if you are in an idle situation and if you are not crossing the threshold, then your character should not rotate, or basically the root bone should not rotate. So to handle this use case, we will create a mode that will symbolize this situation and we will name it accumulate. So if the mode is set to accumulate, that means we are in an idle situation and whatever we have accumulated so far, just nullify it so that the root yaw offset will not change and the rotation root bone node will not be rotating our skeletal mesh, and your character will still be facing in the direction in which it was facing earlier. Now when this situation arises, let's go to another project. See, this aiming can only happen when you are in a idle state. So to have this behavior, do you see my upper body and my head is rotating, but actually my entire body is locked. Okay, we are not moving. Now the rotation that I'm doing with my mouse is being handled by this blend space. So the root bone is not rotating at all. It's my blend space that is rotating the torso and the head. So this will work out only in the idle situation. So when you are aiming, or let's say when you are just looking around like this, we do not want our root bone to be rotated. So whatever amount of yaw you have gathered by moving your mouse under the threshold, we will just nullify it so that my character stays in that place and this blend space use case can work out. Now these are the two use case, but the core idea is to avoid rotating the character mesh in the idle situation unless you cross the threshold, and if you cross the threshold, then we will play the turn in place. That's the entire idea of implementing the turn in place animation, because we want to have that animation play out, and that should only happen if you cross the threshold, and if not, then you just look around. Okay, and that look around can have many use cases like this aiming. And now let's address another situation, that is when you start running or walking. So if I have gained this much rotation, then as soon as I start walking, I want to lock this rotation. That means whatever amount of yaw I have gathered, I will hold it. And as soon as I start transitioning towards the cycle, I will start adjusting my root bone in that direction. Okay, so just look, when I'll press W in the front right direction, it will not immediately correct the rotation. It will correct the rotation gradually once I start transitioning to cycle. See, if I gather this, you see. So this is the situation. So to tackle the cycle state, we will check if the start animation is getting over and the start is transitioning to cycle, or in technical terms, I should say the start is blending out and the cycle animation is blending in. I want to correct my bone based on the rotation or the yaw that I have gathered. So to identify this situation, we will create a mode called hold. That means whatever yaw you have gathered, just hold it there. And as soon as it starts walking and when the start is blending out, I will blend out whatever the rotation I have gathered so that you can gather the yaw again. And this will happen every frame. So these are the two use cases. One is idle, another one is cycle. For idle, we will create accumulate. For cycle, we will create hold. And then the third one is just to blend out these two states. And if you cross the threshold, then we will simply rotate the character. So get to your ABP base. In the idle situation, like I said, we'll create a on update and we will call this update idle state. Now we'll get this node, convert animation state, use this pure function, and then we will search is state blending out. So until unless the state doesn't blends out, we will keep the mode accumulate. So I'll create a enumeration, call it anim struct underscore root yaw offset mode, and the modes will be blend out, then hold, and the last one would be accumulate. Save it, create a variable in the ABP base, root yaw offset mode, and the type would be an instruct root yaw offset mode. Now, initially the value will be blend out, and let's pass the context here. So if the state is not blending out, that means you are still in the idle animation, and we will keep the root yaw offset mode to accumulate. And we will process the value, but for now we just want to set the mode. Then you have another situation in the start, and in the start we will create on update, and we will call this update start state. Again, we will check the same thing whether it is blending out. So convert to animation state is blending out. So if it is not blending out, then we will set the mode to hold. Let's connect the context here. Okay, compile. Cool. Now we have placed our two set commands, and now we can go to update root yaw offset. Here we will deal with the modes. So first situation would be the idle, and that is symbolizes with equal to accumulate. So if you are accumulating, then we would like to nullify that. So we'll create another function that will set the root yaw offset. So set root yaw offset. This is the function that will be updating the yaw. So I'll just call it here. I'll select this function and I'll make it thread safe. And there will be an input, that is the input root yaw offset. Okay, and it would be of type float. So, and we will connect this to true. So the root yaw offset that we are carrying and the yaw that we have gathered in the last frame to this frame, will subtract them. So this is the one situation. Now the second situation, that is the blend out. So if we have to blend out, which is also the case when you will start moving. So in that case, you would like to blend out this smoothly. So to blend out smoothly, we will use float spring interpolation. We do not want to blend out the entire root yaw offset in one go. Okay. So to avoid this, we are using this interpolation, and in that too, we are using this spring interpolation. We'll create the spring state because this pin is a reference. So we have to create a variable where this value can be stored and passed as a reference. So spring state, float spring state, connect this. What is the root yaw offset we have? That is the current one. What's the delta time? And the time is get in delta time. This is what we are receiving in the input here. And we'll keep updating the root yaw offset gradually. So we'll connect this here. Now once all this is done, we will set this root yaw offset mode to blend out. So like I said before, each update in the start or in the idle will happen every frame. So every frame we will blend out. Either we apply it in the opposite direction to nullify, or we hold it and blend it out smoothly as soon as the motion begin. And now here we will update this root yaw offset. So let's bring the set root yaw offset node here, connect this. So we need to get the threshold for the crutch and the standing position. I'll create root yaw offset angle clamped. It would be of type vector 2D. So vector 2D. I'll create another one for crutch. So root yaw offset angle clamp crutch. It should be clamp only, not clamped. Okay. So for the standing state, let's first hit compile. For the standing, we will keep minus 120 and 100. And for crutch, we will keep minus 90 and 80. Okay, now let's bring these two here. Now we will select between them based on whether the character is crutching or not. So I'll check if you are crutching. And then I'll break this to access the values. So first we will normalize this so that we can bring the angle between minus 180 to 180, and then we will use select float. So if these two values are equal in any one of the clamps in the respective situation, then we will just pass the root offset as it is. But if that is not the case, then we will use the range that you have provided to clamp the value. So clamp angle, and the angle would be this, x and y would be this. And this is the value we will pass here. So the clamp angle just brings the angle that you are providing between this range. But if the lower bound and the upper bound of the range is equal, then we cannot use this. We will just simply pass it by normalizing. Now every frame, so if the start state is playing out, it will keep setting it to hold. So the hold case will not let the root yaw offset blend out. As soon as the cycle state start blending in, the start state will no longer set the value to hold. Then this root yaw offset mode will not be changing, and it will be set to blend out, and it will blend out the offset gradually. So this case was to prevent the rotation in the idle state. This was for handling the blend out of the start. And now if I go to locomotion idle, I want to call process turn yaw curve, and we will make it thread safe. And in the update idle state, we will call this. Why? Because if you cross a certain threshold, then we want our character to rotate. Remember when we rotated our mouse more than the threshold, the character mesh rotated by playing the animation, but we have to rotate the root bone on our own. So for this, we are adding this process turn yaw curve value, and the character mesh will be handled by the animation sequence. So I'll create a turn yaw curve value, and when this function will be called, we will store this previous frame value that we have gathered. So previous turn yaw curve value. This is a local variable, mind it, and we will set it. Okay, so this is what we have gathered in the last frame, and then we will check get curve value, that is the turn yaw weight. If it is nearly equal to 0, that means it is almost over. It is about time to play the recovery. So if that is the case, then we can set this turn yaw curve to 0. That means this start gathering all over from 0 again. But if that is not the case, then we would like to know how much is remaining. So for this, we will access this remaining turn yaw, and we will divide this with this value. So we will use this to get the remaining turn yaw curve value. So we will set it here. As time goes by, we will keep updating this. But as soon as you finish the rotation, this will be set to 0 again. And now we will check the previous turn yaw curve value is not equal to 0. If that is the case, then only we will update the root yaw offset. Why is it so? Because when it will be the first frame of the rotation, the turn in place rotation, there will be no turn yaw curve value because you just set it to 0. So let's say when the rotation ends, we will set it to 0, and when the next frame comes in and let's say you rotate it again, this value would be 0 and we are storing it there. So in the first frame this would be 0. So if this is 0, we do not want to update any kind of rotation. Only if it is not 0, then only we would like to rotate the root bone, right? So in the first frame animation, you will not have any curve value, so there is no point of rotating because the character itself has not rotated yet because it's the first frame. So if it is not equal to 0, that means you have rotated up to some amount. So we will rotate the root bone. So for this, I'll call the set root yaw offset. How much and what is the new root yaw offset? Just subtract from the current one, and what would that be? Is the turn yaw curve value this frame, subtract from the previous one. This is the delta, and we will subtract it out and we will pass it. Now let's open our animations, select turn in place, right click, asset actions, edit selection in property metrics. Make sure the root motion is checked, and the compression would be the one that we created in the last distance matching episode. Select it and select this one. It is fine if you were having some different value. Save all. Now we can go to unarmed layers. We created this turn in place variables. Let's set the animations. So search for turn in place. The crutch left goes here. We are going for 90 degrees, and this right here. Then we have unarmed standing, that is left, and this one is right. And now if you play, you can rotate. You see there is no jittery motion or snappy behavior if you are not crossing the threshold. Okay, in the float spring interpolation, I want to configure this so that rotation can happen. So in the stiffness, give value 80, the damping factor would be 1, and the velocity amount, let's half it by 0.5. Okay, so now these are the configurations, and now if you play, you can see after you rotate more than the threshold, it performs the turn in place. And if you don't cross the threshold like this, and if you start walking, you see it adjusts itself. And you can still do the old things like press shift and start. You can see the start animation and the constant running, and then it stops gradually. So that's it for this video. I hope you really enjoyed it and like the video, share it with your friends, subscribe to the channel. Please mention your feedback in the comment section so that this can help me to gather more audience. And in the next episode, we will be implementing blend space for our aim offset. And we will also be implementing the weapon layer because we have been playing with unarmed layer for so long in the series. And now it's the time to introduce the weapons. And as soon as the weapon is introduced, we will be able to take our second step towards the shooting range, where we are going to introduce the bullets, targets, breaking the boxes, killing the enemies. So stay tuned, and if you have any questions or doubts, feel free to mention them in the comment section. The Discord server link is also in the description. You can join it to get the future updates in advance. Until then, take care, and I'll see you in the next episode.